Hi, I'm Bryce Hanna,
Hi, I'm Griffin Evett.
and today we'll be talking about section 6-2, which is properties of radicals.
We will be doing 7 problems that demonstrate the core objectives of radicals.
So enjoy. The problem we're going to do is going to start simple when it comes to simplifying radicals. So we're going to try to find the square root of 52 that's not a decimal. So to do that, we're going to break it down. We're going to factor it out to 26 times 2. 2 is prime, it can't be simplified anymore. 26 can be simplified into 13 times 2. 13 is prime and 2 can be broken down. But now there are two 2's, and so out of 2 numbers you take one of them. So you'll get 2 root 13 because 13 can't be broken down anymore without it being a decimal. And that's your final answer.
Now we're going to do another fairly simple radical problem. So at the start we would take root 36w cubed. And so with this radical we need to try to split it up into 2 separate expressions. And so what we would do is that we would take the regular root 36w cubed and then we would turn it into root 36w squared times w. But we can go farther than this. We can take it so root 36w squared is multiplied by root w. And so doing this will allow us to break up the 36w squared. And so the square root of 36 is 6, and the square root of w squared is w. And so if we do that, we will get 6w is our answer for this, and then 6w times root w will be our answer.
What we'll be doing is root 16a plus 16b. So we're going to try to simplify this the best we can. So first step, you're going to break it down into root 16a plus root 16b separately, so it just makes it more organized. 16 is a perfect square, so it can be 4 factors out of it perfectly. A you can't because it's just a, and we don't know its value. And then you do the same thing for 16b, so you get 4 root b, and that is your final answer because neither of those can be combined or simplified, and the 4's you can't be simplified either. Our next problem is this, which is the third root of x to the 5th over y to the 3rd. The first thing we're going to do is break it down, and we're going to go the third root over x root 5 over third root of y to the 3rd. And then we're going to break down the x's to you get x to the 2nd times x to the 3rd because you add the exponents to get x root 5, and the y just stays the same for now. Whoa. Next step is these 3's are going to cancel, the y to the 3rd and the square root to the 3rd. So then we're going to end up with x squared times x cubed on top over y. And then now we can cancel out this 3 and that x to the 3rd. So then we come to our final answer, which is x root 3, or not x root 3, it's like the square root to the 3rd. X squared over y, because the y was canceled there. The x squared can't do anything with the 3 because those were canceled out. So the x2 just stays there, and the 3 belongs to the square root.
For this problem, we will be taking this number and simplifying it. This number technically cannot exist because you cannot have a radical on the bottom of a fraction. I repeat, a radical as a denominator on a fraction will not work, so that's why we need to simplify this. So, if we take this problem, we will have to first start off by multiplying by c squared root 3, which is kind of confusing, I know, but it's fine, it's fine. So if we do that, we will get 4 roots times root 3c squared on the top. And then on the bottom, though, since we did this, it would be root 3c cubed.
I'll just do what you tell me to.
Alright, I'll edit that out. So, restarting, we'll have this which is root 3 of c cubed, even though it really looks like a cube. So if we have this right here, this would equal regular c, because c cubed 3 makes sense, right? So as our final answer, we would get 4 root 3c squared over c.
Doing will be multiplying radicals. So it's root 42 times the square root of 30. So first we're going to simplify these, and 42 is 7 times 6. 6 can be simplified into 2 times 3, but all those numbers are now prime. They can't be simplified anymore. 30 is 5 times 6, and then you get 2 times 3, and none of those can be simplified any further either. So now you combine the remaining numbers, which are these 6 numbers, and there are 2 2s and 2 3s. So out of those, you take one of each and multiply them. So you get 2 times 3 equals 6 is on the outside. And then you have 7 and 5 left over. You multiply those and put those on the inside. And you get 6 root 35 as your final answer, because 35 can't be simplified any further.
I was thinking.
So now we're going to do our most advanced problem of this video. So, this is the final graduation problem that we will be doing. So we will take the third root of 81 over 8. So, we just got ruined. So, to start off this problem, we will need to split this fraction up. So, that will be 81, or the third root of 81, over the third root of 8. And so, the way the third root works is that the original number has to be cubed and equal these. And so, if we take the third root of 8, that would be 2 actually. So, on the bottom of our equation, now we have the number 2. And if we try to do that with 81, we actually can't do that with 81, but we can try to break 81 up into something that will have a root 3. So we can break 81 up into 27 times 3. And if we do that, we will actually get 3 over here, because 3 cubed is equal to 27. So we will get 3 root 3, because this 3 over here cannot be broken down at all. And this is our final answer.